on example 1, find the slope of the graph of f of x equals 2x minus 3 at 2 comma 1. Is this some kind of trick question? Isn't the slope of this graph just 2? Well, of course it's 2. Just humor me for a second. You're going to see that this particular example is the equivalent of trying to kill a fly with, say, an atom bomb. We're going to show that we can get 2 for the slope using this definition of the tangent line and its slope using the limit definition. All right, so we're going to illustrate it with this line with a slope of, I don't even know what the slope is. I'm going to have to use calculus to come up with it. So we're going to write m is equal to the limit as h goes to 0. And this is the way that I usually work these problems, so I can remember how to set it up. I'm just going to set it up before I start plugging things in as f of, and the x value that I want here, the a value here is 2. So it's 2 plus h minus f of 2 all over h. So just take a look. I set it up exactly like this. This in here, this a value, that's where I'm trying to find the slope at, right? That's where I'm trying to find the slope of the tangent line. And this h is the variable for the limit. It's the thing that I'm trying to collapse down to 0. All right, then, let's go ahead and use our function to find f of 2 plus h and then also f of 2. Actually, I already know that. That's 1. Limit h goes to 0. 2 plus h, just plug it into the function. It's going to be 2 times 2 plus h minus 3 minus 1, right? It's right there. All over h. Hey, I wonder what would happen if I directly substitute in a 0 right now. Well, watch what happens, shall we? If I plug in a 2 here, that makes this a, no, not a 2, a 0, a 0. What am I saying, a 2? 0. That makes this a 2. 2 times 2 is 4. 4 minus 3 is positive 1, and then minus 1 is 0. 0 over 0. Well, what do you know about that? 0 over 0, indeterminate form, which means that we have to fix it. And we're going to fix it, since this is basically polynomial. I mean, sure, it's linear. And we're just going to expand things out, collect some like terms, and you'll see things will nicely, conveniently, satisfactorily cancel each other out. So distributing this 2 through there, I have 4 plus h. Going ahead, combining these constants, minus 4 over h. Wait a minute. I forgot to distribute the 2 through that. Why didn't you guys stop me? Minus 4. There we go. I almost got a slope of 1. Yeah, anyway, so cancel these guys out. And I have, if you need to see it one more time, the limit as h goes to 0, 2h over h. I'm still not done canceling, because if I plug in 0, I still get 0 over 0. Common factor, h divided by h is 1. And I have the limit as h goes to 0 of 2. That's equal to 2. What did we just find there? We found the slope of the tangent line. And the slope of the tangent line on a line is actually the line. There you go. So I'm going to actually propose something to you, and that is, those of you who might have brothers or sisters, like younger brothers or sisters that are first learning to compute slope, and if they ever come to you with questions like, I'm having trouble with these slope questions, can you show me what to do? You show them this, and you wreck their math career for the rest of their lives. Like, I don't understand anything about slope now. It will be funny. Just take my word for it. It's going to be hilarious. All right, let's look at the second example here. So example 2a, find the slope of the graph f of x equals x squared plus 1 at negative 1 comma 2. Okay, so this is more like it. This is one where we would actually use some calculus in order to find the slope, because it's not like, hey, there's a little m stuck in there already. All right, what am I trying to do? I'm trying to go over here. So my a value for my little slope is going to be this negative 1 here. So I'll set it up just like I did before. The limit as h goes to 0 of f of negative 1, because that's my a value, plus h minus f of negative 1 all over h. Always fill in a little pattern that's like that, and you'll never get it wrong. Oh yeah, by the way, did I mention this? Yeah, this is a limit that you want to have memorized. Not the specific one, but you know, this kind of thing. Or if you prefer the H's, that kind of thing. All right, so now it's time to plug this business into this business and see what happens. I'm going to have negative 1 plus h squared, and then plus 1. Hey, don't forget about this guy. It's like, don't forget about me. Minus, and my f of 1 conveniently is already given to us as, okay, just a second. All right, I saw it this time. I didn't write down the 1. Minus my f of 1, negative 1, which is conveniently given to me right there again as 2. That's not always going to happen. Sometimes they just give you the x value. You'll have to plug it into your function so you can find the y value. I think you can handle it. All right. Again, if I were to plug in 0, I wonder what I would get for this limit. Plug in 0 here, I'd get negative 1. Negative 1 squared is 1. 1 plus 1 is 2. 2 minus 2 is 0. 0 over 0. I wonder how we're going to resolve this one. Hey, look, we have something that looks quadratic. I wonder if I can expand it, maybe combine some like terms and stuff. Maybe stuff will like conveniently cancel. Let's just try it and see. Limit h goes to 0 of, I'll have to expand out this binomial here, the square of a binomial, and it will be positive 1 minus 2 h's, and then plus h squared. All right, and then combine these constant up as a negative 1 over h. See, I told you, like, it's almost like I've done this before. All right, now then, am I done yet? I don't know, if I plug in a 0 here, I just get 0 across the top, 0 on the bottom. No, I'm not quite done. Maybe what I can do is factor out a common factor of the h's that are right across the top here. Limit h goes to 0 of, pull out an h, negative 2 plus h, 1h, yeah, over h. And just like before, the h's cancel. Nice, all right. Which leaves me with the limit as h goes to 0 of negative 2 plus h. Now can I directly substitute that 0 in? Sure can, and I get negative 2. Hey, let me ask you a question. What did we just find? We found the slope of the graph at this particular point. So if I were to graph a parabola, in this case it is the parabola. Why am I on pink? Let me change this. Let's come on, I've got all of these colors, this big box of crayons. I can change the colors up a little bit. All right, so here's my parabola. It's almost like I used a TI calculator in order to graph it. Anyway, so if I were to use red for tangent line, and then right here at negative 1, and find the slope of that line, it would be negative 2. Not only that, it's also the slope at that particular point on the graph. Isn't that fantastic? I still wonder, it's easy and all. It's just a lot of work. I wonder, is there an easier way to do it, though? Is there a way that's less work? Probably not. Anyway, this last part of this question here, follow-up, write the equation of the tangent line to the graph f of x equals x squared plus 1 at negative 1, 2. So whenever you write in the equation of a line, you essentially need two pieces of information. You need a point, and you need a slope. Well, the point's obvious, it's just given to us. And the slope, hey, we just found that right there, it's negative 2. And as a matter of fact, I'm going to highly recommend that you just put it into point slope form. Y minus y1 is equal to the slope times x minus x1. Right? Do you remember that from Algebra 1 in geometry? Of course you do. You've probably used it every day of your life. It has probably saved your life on numerous occasions. All right, let's just plug our stuff in and then call it a day. Why am I changing crayons? I don't even know. Y minus 2 is equal to my slope, negative 2, and x minus a negative 1, so plus 1. All right, you know what? This right here Is this an okay form? Can I leave my answer like this? Yes, you can, especially if it's a free response question where you had to write the equation of a tangent line. Is that something that they would expect of you? Absolutely. And this is perfectly acceptable as an answer. You might have a multiple choice question, though, where you have to match it up. And if you have to match it up, y minus 2 is equal to, distribute the negative 2. Let's see if I can handle it this time. Minus 2. I may have, in fact, pulled it off. Add the 2 over, y is equal to negative 2x. So let's just, play around with Desmos just for a second because this video is not long enough. I haven't hit the 20-minute mark yet. Let's do a new blank graph. And let's graph both of these things together because I'm curious. Y is equal to, it was x squared plus 1, I believe. All right. And then on the next one, let's do our tangent line as y is just equal to negative 2x. Remember, the y-intercept just kind of went down to 0. So y is equal to a negative 2x. Well, would you look at that? All right, remember this business? Here, let's collapse that. We can get rid of this and then just kind of zoom in on that and zoom in. Oh, it's so satisfying. Look at what we just did. Look what we were just capable of doing with some calculus. All right, I think I'm going to end that particular question right there. When we come back, we're going to make it a little bit tougher for sure because these are like baby problems. We need some grown-up calculus problems.